Welcome to all. This is the third part, that is in the design of shear reinforcement by limit state method for beams. One part I considered procedure for vertical stirrups, design using only vertical stirrups. Second one, numerical example. This is procedure for design of shear reinforcement for beams in the form of once again vertical stirrups only when cranked or bent up bars are available as additional shear reinforcement for resisting shear. I will not tell too much because so many information is given earlier in working stress method. At that time I told identical procedure for limit state. So those who are serious, first go to working stress method. 4 classes are uploaded there. Go through thoroughly, see all the statement and explanation, then come here. Okay. See, class. That is, I told all this one. Remember, this is extra bar. Class means even now design is using vertical stirrups only. Remember, vertical stirrup is the main. This cranked bar is a additional help. It is not the main. So therefore, earlier 2 classes we designed using only vertical stirrups. Now vertical stirrups only we are designing, but this cranked bar will give you little extra strength, or what you can tell, it will slightly reduce the force for vertical stirrups. Okay, start. Data. See, I will tell one thing. Till one particular stage, procedure same as the previous part for vertical stirrups. This colored will come only when shear reinforcement is required. So till you decide shear reinforcement is required, you never bother about this green color one. Okay. B, D, AST provided for cross section, concrete and steel grade, factored shear force for the cross section considered VU. Now here extra diameter and number of bars of cranked bars, either called cranked bars or bent up bars or inclined bars. Okay. Which is available for resisting shear. Procedure. See, ditto same. Find nominal shear stress tau V, VU by BD. I told in the class, it is not nominal, it is the actual stress to be resisted. Okay. For given concrete grade, get tau C maximum. I will not tell now. It is told more than 10-15 times. Compare tau V with tau C maximum. For safety, tau V should not exceed tau C maximum. If tau V exceeds tau C maximum, cross section should be redesigned. How to redesign? No, not covered here. Long back I told. But anyway, in our present course, decision is what? Cross section to be redesigned. Okay. Now, consider the case of tau V not more than tau C max or tau V within tau C max. Means what? Shear stress is within the limit. Okay. Proceed further. Safe. Cross section provided is okay based on shear. One powerful note I told you. This is also not required. Comparing tau V with tau C maximum is only a check for safety or permission to proceed further. This comparison will not tell whether shear reinforcement is required or not. Now, whether shear reinforcement is required or not will be decided only after you compare tau V with tau C. Tau C is next coming up. Okay. Now I'll change it to next step, calculation of tau C, which you already know. Based on PT, get tau C. Then compare tau V with tau C. If tau V is less than tau C, shear reinforcement is not required. If tau V is more than tau C, shear reinforcement is required. I will write once again. So, next step, get tau C. That is allowed shear stress for concrete alone without shear reinforcement. Without shear, short form RI. IS code told design shear strength of concrete without shear reinforcement, or how much shear stress concrete alone can resist. I have told money matter, etc. So many things. You study all the classes, it will be clear. Okay. To get tau C, find percentage of tension reinforcement provided for cross section considered. That is very important. That is PT provided. PT provided equal to 100 into AST provided divided by BD. Then get tau C from table number 19 considering given concrete grade, because different concrete they given different values. Okay, now right here intermediate values to be obtained by linear interpolation. You should write. Okay, now tau C is over. Next step, compare tau V with tau C. Those who want write shear stress to be resisted. How much shear stress concrete alone can resist, or how much is the bill, money matter, how much is your own money. So if the bill is less than the money in the pocket, you are happy, no help required. Okay, now I will write case 1. Case 1, tau V is less than or equal to tau C. See, still now that bent up bar has not come. Again write shear stress to be resisted is less than the capacity of concrete. Okay, therefore shear reinforcement is not required to be designed. No design, nothing. Not required to be designed. Therefore, provide nominal, or sometimes people tell minimum shear reinforcement in the form of vertical stirrups. Now, at what spacing? At maximum permissible spacing as per IS code. Why? Because why waste? How much IS code permits, give that much more spacing, save the steel. Okay, now do one thing. Right, I will write somewhere here. As per IS, I am writing here for some reason, you should write it here. What I am writing here you have to write. As per IS code, maximum permissible spacing for vertical stirrups is 1, 300 millimeter. Second one, 0.75 times D. Next one, ASV into 0.87 Fy divided by 0.4 times B. But IS code condition is that Fy is not more than 415 Newton per mm square. Okay, now among these three, least value. Now, therefore, decide maximum permissible spacing. Only one value. Which value? The least value. Decide it and provide the stirrups. Over. This is the case when your tau V is less than tau C. Make a note. Till now, those cranked bars will not come for any calculation. So those cranked bar will come only when shear reinforcement is required. That is not case 1. When you go to case 2, okay, I will start fresh here, case 2 now. That is tau V more than tau C. Fresh I will start. Okay, right now only. That will be there only. Don't want to waste time. Now write. Continue procedure. Case 2. Tau V more than tau C. If you want, write shear stress to be resisted, how much shear stress is allowed or resisted only by concrete, or how much is the bill, how much is the money in the pocket. Like bill 500 rupees, in the pocket only 200 rupees. Help required. Right? Therefore, first of all, we don't know how many times I told. First of all, shear reinforcement, short form, is required to be designed. To be designed. Okay, first make a note here. Now, those cranked bars will come into picture. Okay, start first. Make once again note. Shear reinforcement is always in the form of vertical stirrups, even if crank bar is there. So, first decide diameter and number of legs for vertical stirrups. You can make a note. Most popular is 2-leg right or over. Then get spacing of vertical stirrups. Remember, that is called SV. As per IS code, actually derived formula, SV equal to 0.87 Fy into ASV into D divided by VUS. This you all know it. Now remember, this is based on strength. This repeatedly I am telling. Means whatever spacing you get, you cannot give more. Okay, now, little more I will explain. One by one, start. ASV is cross-sectional area of legs of the stirrups. This you already know it. I am giving full procedure, equal to 5/4 of diameter square into number of legs. Okay, that also over ASV. Then, as per IS code, Fy should not be taken more than 415 Newton per mm square. Remember, for vertical stirrups and also later for those cranked bars. Even for cranked bars also. Okay. So make a note. If the Fy is within 415, take whatever is Fy. But in case Fy is more than 415, take only 415. That also over. Now, VUS is ultimate or factored ultimate shear force to be resisted by vertical stirrups. Vertical stirrups. Now, or you can tell VUS is what? Factored shear force to be resisted by vertical stirrups. This all I am writing. Still I am not considering that one. So formula VUS equal to VU minus VUC. Now one small problem comes. See, whatever is the shear force, subtract the shear strength of concrete, remaining is to be taken by stirrups. This was the case when only stirrup was used. But now suddenly crank bar will tell, I am also there. Okay, thank you. Welcome, come. Therefore, the IS code used the word ASV. It is for shear reinforcement for both stirrups and cranked bars. VUS also they are using for both stirrup and cranked bars. So just to differentiate, what I will do, I will put ASV ST, ST suffix for here also see VUS ST, ST. ST means stirrup. Okay. So here VUS shear force to be by vertical stirrups. VUS ST. So VUS ST equal to VU minus VUC to whatever is the shear force, subtract whatever is resisted by concrete alone, and also subtract whatever is the shear strength of cranked bar. Oh, first time it came. Okay, right. Everything, see, in the formula for SV, VUS ST, earlier this ST was not there. See, now right. VUS ST is ultimate shear strength of, I write, cranked bars. Oh, sorry, VUS CR. Okay. VUS CR of cranked bars. Now actually it is night around 2 o'clock, so that's why little feeling sleepy. VUS CR is the ultimate shear strength of cranked bars. Now, very, very important now. As per IS code, VUS CR equal to 0.87 Fy into ASV for CR into sin alpha. Okay, right, one by one. ASV CR is cross-sectional area of cranked bars. You see, you know number of bars and diameter. Okay. Alpha, I have no time here, right? Space problem. Angle of inclination of the cranked bar with axis of the beam. In absence of data, take alpha 45 degrees. Okay. Now, again, Fy not to be taken more than 415 Newton per mm square. And now, very, very important, right? Very, very important. In IS code, there is a condition for VUSCR. I will do one thing. First, I will write exactly condition as per IS code. Then I will give easier version. Remember, this all explained for you in working stress method, where you, instead of VUSCR, I told VSCR. Okay, see. IS code, page number you search. When bent up means or cranked bars are provided, are available, that is better, are available for resisting shear. I am slightly changing the language. Resisting shear or as additional shear reinforcement. Their contribution means strength contribution. Their contribution towards shear resistance shall not be taken more than half of shear strength of total shear reinforcement. This I explained in working stress method. I told some money matter also for you. Go back there and study it. But remember, this will be confusing. Those who are having good idea, they can understand. But many people will have difficulty. So, or in simple words, I will write here now, space problem, I will start here. In simple words, this all I remove now, nothing required. This formula I require still, in simple word, it means, or, see I write here, or in simple way, it means VUSCR should not be taken more than half of Vu minus Vuc, fully explained. Or you can tell in mathematical form, VUSCR not to be taken more than half of Vu minus Vuc. Therefore, what do you do? Get the conditional value. Get this, see, this one, this is a conditional value, see right here. Get this conditional value. Now, last step, over. Now, VUSCR to be considered equal to, see, to get VUST, you require VUSCR to be considered is either your VUSCR calculated, where is it? Here, see, this one, right mark, calculated, or VUSCR maximum limit. I'll put double right, this one. Double right, okay. Either this value or this value, among the two, whichever is least. Okay. Whichever is least. Okay. Now, so simple. You compare this, whatever you got by formula, strength substitution, compare with this conditional value, take whichever is least, over. Now, see, lastly, substituting where? Here, see, substituting, get VUSST. See, VUSST equal to VU, already done, already over, minus, you should write here, that is, write once again write, VUSST equal to VU minus VUC minus VSCR. Then, last step, substituting where? In this formula, get spacing of vertical stirrups, that is SV, remember, strength based. Next, refer IS code and get maximum permissible spacing for vertical stirrup. Okay. Write once again here, good for health. Write this one. Not decide, okay. Once again write here. See, lastly, therefore, decide maximum permissible spacing as per IS code, that is the least value here. This statement write once again, good for health. Right, all that one right here. Then, lastly, decide spacing to be provided. For vertical stirrups and provide. How? That also not required. Go right if you want. Whatever spacing you got from strength, right here, it is spacing SV you got from strength, got strength based, or spacing maximum limit as per IS code among the two, whichever is least. This is told so many times earlier. Okay, least. This will complete the procedure. Now, last one I will upload. This is third part. Fourth part, numerical example. Once again, 3 questions. One question, unsafe. Second, shear reinforcement not required. Third one, critical question. With that one, shear part will be over. Next time, lastly, I will upload one T section. Structure analysis of T section. So many got confusion. I will clarify everything systematically.